Lesson 9-5 using the percent proportion, and in this lesson you learn to use the percent proportion to write fractions as percents and to solve problems involving percents. Why is this important? Because the percent proportion is used to make and analyze circle graphs. Let's take a look at this application in physical therapy. If you were looking for a bodybuilder, you would probably head for the local gym. But did you think of looking at the medical center? You may not find Arnold Schwarzenegger there, but you will find physical therapists. Physical therapists build bodies by helping people to use exercise to regain their strength after an injury or surgery. Peggy Harper is a physical therapist for the Friday City Schools in Findlay, Ohio. She is working with Chris McDaniel, a football player who is recovering from a knee surgery or knee injury. The muscles around Chris's knee are weak from lack of use, so Miss Harper uses a dynamometer to compare the strength of the recovering leg to the strength of the uninjured leg. So Miss Harper determined that Chris can lift 70 foot-pounds with his weak leg and 125 foot-pounds with his strong leg. Using these numbers, she can find the percent of strength of the injured leg. And this is where our lesson comes in. And we talked about a percent is a ratio that compares a number to 100. Percent also means hundredths or per hundred. So the symbol of for percent is a diagonal line with two little zeros on both sides of the line. So to find the percent of a strength of the weak leg, we set up a proportion. Okay? And the proportion is foot-pounds lifted with the injured leg over the foot-pounds lifted with the uninjured leg equals the strength of the injured leg over 100. Okay? And using this per proportion, we now have 70 over 125 equals x over 100 because that's what we want to find out, the strength of the injured leg. Okay? And using what we learned in the previous lessons and how to solve proportions, we use cross products. We multiply 70 times 100 and 125 times x. So we end up with 70 times 100 equals 125x. And we simply divide both sides by 125. Okay, so you have 7,000 divided by 125. You'll end up with 56. Okay, so the injured leg has 56% of the strength of the strong leg. So in the proportion that Miss Harper used, 70 is the percentage or the P. Okay, 125 is the base. And the ratio 70 over 125 is called the rate. Okay? And from here, we end up with 70 over 125 is equal to 56 over 100, wherein percentage, okay, over the base is equal to the rate. Okay? Again, do not confuse yourself. The percentage does not mean your rate, because if you look at this carefully, okay, percentage does not mean the number with the percent sign. So even though it's called percentage, okay, it is not the number with the percent sign. The number with the percent sign can be found in your rate. Okay? If R represents the number per hundred, this equation can be rewritten as P over B equals R over 100. So getting the equation from the previous page, okay, and the equation from the previous page is P over B is equal to capital R. It can be also rewritten as P over B is equal to lowercase r over 100. In this case, r is equal to r, lowercase r, over 100. So this proportion is called the percent proportion. Okay, so you can use the percent proportion to express fractions as percents and to solve percent problems. Let's take a look at example number 1 and see how we can use the percent proportion to express each fraction as a percent. And we have 9 over 16. And using the percent proportion, okay, which is P over B equals lowercase r over 100. This now becomes 9 over 16 is equal to 9 over 100. So we simply replace 9 with P and B with 16. So using cross products, we now have 9 times 100 equals 16r. Dividing both sides by 16, 900 divided by 16 will give us 56 and 1/4 r. That means, okay, 15 over 4, okay, sorry, 9 over 16 is equivalent to 56 and 1/4%. Okay, let's take a look at 1b, example 1b, 15 over 4. We want to express this as a percent. Again, we use the percent proportion P over B equals R over 100. And we substitute the values for P and B to be 15 over 4 equals R over 100. Using cross products, we end up with 15 times 100 equals 4 times R. And then 1500 divided by 4. We divide 4 to both sides so that we undo 4 on the right side and isolate R. End up with the value R equals 375. So 15 over 4 is equivalent to 375%. Okay? Let's take a look at this one. There are 3 basic types of percent problems. Using the proportion 1/2 equals 50 over 100, you can see that the types are listed. The types are related as shown below. So let's use 1/2 equals 50 over 100 as an example. So in this example, we're looking for the number 1, which is our percentage. So we can write this as what number is 50% of 2. Okay, so what number is our percentage? 50% of 2. And if you notice, 2 is considered our base. Okay, so if 2 is our base, that is our base. Okay, and 50% is our rate. Okay, let's take a look at the second scenario. We're now looking for 50, okay, or our lowercase r. So in this scenario, these are the wordings that you could probably find. 1 is what percent of 2, and we're looking for the rate here. And again, this is 2 is our base, 1 is our percentage. And the last scenario, we're looking for 2, which is our base. So this is 1 is 50% of what number? Okay? In the first scenario, we're looking for the percentage. In the second scenario, we're looking for the rate. And in the third scenario, we're looking for the base. Now take a look at all these examples. If you notice, the word after of, the number after the word of is always your base. So that's one tip that I can give you when you look at the percent proportion. The number after the word of will always be your base. Okay, so let's take a look at example number 2. 68 is 20% of what number? So the first thing you can do here, okay, is to identify your base. Again, what did I say? Okay, the base is always after the word of. So in this case, this becomes your base. What number? 20% is your rate, and there's only one left. 68 is your percentage. Okay, so if you use that, go to the formula P over B equals R over 100, substituting the values, 68 is our percentage, and we're looking for the base, is equal to 20 over 100. Okay, using cross products, we end up with 20B, or sorry, 68 times 100 equals 20B, and we want to solve for B by dividing both sides by 20, and you end up with 340. So the basis is 340. So to rephrase this particular question, 68 is 20% of 340. Okay? And going to the last example, you can also use the percent proportion to find the percentage when the base and the rate are given. So we're given the base and the rate. You can also find percentage. And let's go back to the beginning of the lesson in terms of Miss Harper. Physical therapists usually set a goal of bringing an injured leg up to at least 90% of the strength of the strong leg. How many foot-pounds should Chris expect his injured leg to be able to lift when the physical therapy program is complete? So for the program to be complete, the strength of his leg should be 90% of the strong leg. Okay? So just like what we did with Miss Harper, we use the percent proportion to solve for the number of foot-pounds. Okay, so we set up our percent proportion, P over B equals R over 100, and it's saying in this problem we are looking for the percentage. Okay, we're looking for the percentage because this is the strong leg, and it should be 90% of the strong leg. So we replace B with 125 and R with 90, and we use cross products. We end up with P times 100 equals 100 times 90, and then that ends up with by dividing both sides by 100, we isolate P, and we end up with P equals 112.5. Okay, so Chris should expect to be able to lift at least 112.5 foot-pounds with his injured leg when the program is complete. The secret word for this lesson is Buckeyes. The secret word is Buckeyes. Okay, and that is our lesson. Thank you for watching.